Okay, this boat problem is just kind of a mean problem. All right, so we're going to try to get to this dock. So we know the resultant vector needs to go from here to the dock, and we know that that's 20 degrees upstream. That the dock is 20 degrees upstream. That's what we have to eventually have happen. And what it'd be nice if we knew the velocity of that right now. We do know that it's 815 meters, and we're going to get there in 10 minutes. But you'll notice that all the other velocities in this problem are in kilometers per hour. So we need to figure out, before we even start the problem, what is the velocity in kilometers per hour that we're going to go along that to get to that dock. And that's going to be some dimensional analysis. It's 815 meters in 10 minutes. And we want to convert this to kilometers per hour. So that's distance over time, but that's in meters per minute, so that isn't correct velocity. So we're going to do 1,000 meters is 1 kilometer. Aha, I found you, and we're going to cross those off. And then we're going to do, let's see, we're going to do 60 minutes in 1 hour. Aha, I found you. Cross off the minutes. And we'll take 815 times 60, divide by 10, divide by 1,000, and we're going to get 4.89, I believe, kilometers per hour. So that's going to be this vector right here, 4.89. Okay, so we need to get to that dock. So we know the river is going to flow down. So if we just head straight towards the dock, we're not going to make it. The river is going to take us more downstream, and we're going to end up on the other side of the river, somewhere downstream of the dock. So to make sure that we get to the dock, we actually need to have a heading that's out here farther up, like this. And we'll take it all the way to the other side. And then to that vector, we're going to add the river going down. And I didn't draw it really to scale, probably too much. The river is 3 kilometers per hour. 3 kilometers per hour. I won't worry about sig figs right now. So I have a side. Right here, 4.89. I have a side here, 3. It'd be really nice if I had the angle in here, because if I did, then I could use side angle, and I could use a lot of cosines to figure out what this velocity is over here. It's not too hard to find that angle in here. If we draw kind of a horizontal here that's parallel to this one, then this is 20 degrees, and that means this angle, these are alternate interior angles right here, this angle right here, and this angle here are alternate interior angles, transversal across 2 parallel lines. Hopefully you remember that kind of stuff. So this angle here would be 20 degrees right here. And we know that this is 90 degrees. So 90 plus 20 would give us this whole angle right here. In between these two would be 110. So we can use a lot of cosines to figure that out. So we'd have c squared would equal 3 squared plus I'll just make it 4.9 squared, minus 2 times 3 times 4.9 times the cosine of the angle between the two legs is 110. And so to find c, we'd square root that. To find c, we'd square root this whole thing. And then, so the vector comes out to be like 6 point something. It's going to be, we need 2 sig figs, don't we, in this problem? Yep. So it's going to be 6.6 kilometers per hour is how fast we need to be going along here, 6.6. Okay, we also need the bearing. How many degrees upstream from the 0 is that vector? Well, we know it's 20 to there. So all we need to know is what this angle is in here, and we can add it to the 20. So we can use the law of sines. How do I find this theta here? I could do sine of that angle over the opposite side, which is 3, equals the sine of, let's choose the other angle we know, 110, over its opposite side is 6.6. So we can cross multiply and divide, and then we have to do the inverse sine to get that angle. And that angle, if you do it all right, if you're in degrees, if you're in radians, you're going to miss all these. If you're in degrees, then you should get the angle to be, and if we want 2 sig figs, it should be like at 45 DEG, 45 degrees, and then you got to put upstream. 6.6 kilometers per hour at 45 degrees upstream. Hopefully that'll be correct.